Great.
Yeah, good teacher, Teacher Zaitan. I think I'm starting to get the hang of it.
It's just chapter one, don't worry. Soon enough, you'll lose the hang of it.
5 minutes later.
Or have you gone quiet, Teacher Zaitan?
No, I'm just trying to evaluate between our equations here. Nothing to worry about, don't worry.
But we don't have sum of x squared either in this case.
But we do, though.
No, but we don't.
But we do.
Alright, this video is going to be slightly different from what you're used to seeing on this channel. I'm going to show you a lesson that I had with one of my tutoring students. We've been doing tutoring for over 7 months now, and side note, if you do want tutoring, it's the second link in the description down below. Currently, he's been struggling with understanding coded data, but the issue is that he's learned coded data before and has understood it. So we decided, why not flip the roles? He's going to relearn coded data by himself, and then he'll teach it to Mika as well. Teaching is the greatest form of learning. So this is that lesson. And yes, I was intentionally trying to be a difficult student. So without further ado, like the video, subscribe, and let's dive right in.
Mind you, I watched your video for this. So
You watched what?
I watched your video. So if you don't learn, scan the world.
Yeah, don't blame it on me.
Now I'm blaming it on you. Okay, let's understand what coded data is first, right?
Right.
It is a way of us basically making big numbers small, right? It's a way for us to simplify how we represent data.
Okay.
So usually, data is given, for example, you have a bunch of x values, like 101, 102, 103, 104. Right. And then when you code the data, you usually subtract by like some sort of easy number. Like you can say something to make the data more representable. So you'd go x minus 100, and so now your data is just 1, 2, 3, 4. So that's big.
Okay, I've got a question.
Oh, flip. No, no questions. Man. No questions in the last.
What if my data set, we use y, what if my starting data set is like 101 and then 1002
Mhm,
and then 1400 and then 2800
mhm, mhm.
and 4200?
Right, right.
Would it make sense for me to code this data? And if so, what number would I use to code?
A data like this, it's probably not wise to code it. Uh, reason being is you'll struggle to find any sort of way to code it. For example, subtracting by 100 here or by 1,000 won't work in any way. So no matter what sort of number you pick out, I don't. It's not wise to code data that doesn't necessarily. That's not that doesn't sort of follow a sequence or or is close to one another. Let's say. Otherwise,
Okay,
it becomes very complicated.
okay. Thank you, teacher said that.
Okay, for any other questions, go do your homework. So forget that. Um, okay, so when you code data, um, you need to, well, to solve for coded data questions, because that's what matters the most. We need to keep three formulas in mind here. And the first formula is that x minus a bar, right, is equal to x bar minus a. So what does this mean? Right. This means that the mean of the coded data is wait, that's a good question. What does this mean? Uh give me a second, let me think.
Okay.
No, yeah, mean's not the same. Yeah, never mind. Got that wrong. I was about to say that the means are the same, but they're not. Don't think that the means are the same. They're not. The the mean of the coded data, so x minus a bar, is equal to the mean of the uncoded data minus a.
Okay.
They're not the same.
Okay.
Although for standard deviation, so sigma of x, that would be equal to sigma minus, that would be equal to sigma x minus a.
What does that mean?
This means that the standard deviation of the non-coded data and the standard deviation of the coded data are the same.
Why would they be the same? I thought we changed our data.
Now, us changing our data does not affect standard deviation. And the way for us
Why?
to do this, give me a second, I'll tell you how we can do this. So I just like see the formula. Okay. Code should be nearly info. Right. Um, this is a very good question. Sorry, I need to do the formula, mate. That's not gonna help me here. I
Are
should
you stumped, Teacher Zayden?
I'm not really a good teacher. I can't lie. It's my first day. A bit nervous.
First day on the job.
First day of the job, yeah, for sure. It's a very good question.
It is.
So you still need to know that, though. I think we can work without that. Just know that they're the same.
Okay. I think, can I offer my opinion, Teacher
Yeah,
Zayden?
please go ahead.
Okay. So, from what I understand,
Mm.
standard deviation is the average distance of the points from the mean.
Yeah,
So, suppose I was to add an extra value to the data set you proposed at the beginning,
right,
the min of this original data would now be 103.
right,
So when we're talking about standard deviation, we're talking about the average distance of all the points in this data set from the mean.
right, right.
So when we code our data, our mean becomes this 3, and the average distance from the mean
Right,
is still maintained. It doesn't change. This point is still -2 units from the mean.
right, right.
That point there is still -1 unit from the mean.
Uh-huh.
And then this point here is +1 unit from the mean. And this point here is +2 units from the mean.
Right.
So as long as that distance away from the mean does not change, then our standard deviation does not change, and therefore variance.
Okay. 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 Yeah, I was making sure you knew it too. Just testing you.
Okay, okay.
Yeah, no, I definitely knew it. I definitely knew it.
All right.
Yeah, and so as you said, variance will be the same. So sigma squared of x would be the same of um would be the same as sigma squared x minus a, right? So that pretty much covers the three formulas that are necessary for you to solve the bulk of questions. You'll come to see that primarily primarily you use the mean equation the most.
Okay.
Besides that, there's actually not much I can tell you about this stuff.
Okay. Do you want to walk me through an example? and
Yes.
explain to me how I should approach these coded data questions.
Yeah. Let's see if I can do the example. It's a bit doubtful. Why don't we choose a question to practice on so I don't embarrass myself?
Yes, this is statistics 1. I think we have the worksheet. Which question would you like to walk me through?
Oh, the first one.
Okay.
Definitely the first one.
Shall I reach the question?
No, don't worry. No, let me explain this question to you.
Okay.
Then you can try one yourself. See.
Okay.
Okay, so for n values of the variable x, it is given that sum of x minus 50 is equal to 144 and sum of x is equal to 944. We want to
Mhm.
know the value of n,
Right.
right? So what are we actually seeing here? So our data is coded in the form of x minus 50, right?
Okay. Mhm.
So we should know that x minus 50 bar, right? You can write this down just so you recall, so you remember it.
Okay.
That's equal to, right, the sum of x minus 50 over n.
Where is this coming from?
Right. This is very simple. We're saying that the sum of the mean of the coded data, right?
Right.
In order for us to get it, we should have the sum of the coded data over how many values of coded data we have. Right.
Okay. Just to make sure I understand,
Right.
are you saying that I'm summing up these coded values
Yes,
and then dividing by how many of these values I have?
indeed.
Oh, okay. The notation just makes it look a bit weird, but okay.
So Andrew, I
Makes sense.
you know this stuff. But yeah,
So
no,
breaking courage.
it's just the no, we're just applying the sum of the coded data. So we're applying the minus 50 onto each x value, and we're dividing it by how many values we have, because that's how you get mean in general. In
Oh,
general, the formula for mean is just the sum of x values over n.
mm,
Right. So it's not much difference. It's the sum of the coded data over n. Okay. So what do we know though? We know that the sum of x minus 50 is equal to 144. So we can now say that x minus 50 bar, right? So the mean of the coded data here, right, is equal to 144 over n. Just simple substitution right there,
right.
right? Okay, now we need to apply one of the three formulas that we use there. We know that x minus a bar, right,
Mhm.
is equal to x bar minus a,
Right.
right? Important. So what are we saying? The mean of the coded data is equal to the mean of the uncoded data minus a,
Mhm.
right? So let's look to let's look to understand how we can um sort of solve for n here, because that's our objective, right?
Okay.
Us saying x minus a, x minus 50 bar, right?
Mhm.
How else can we represent that? Like, I'm asking you, how can we represent this?
144 over n.
No. Leave 144 over n aside. How can we rewrite x minus 50 bar? What is x minus 50 bar the same as?
It is the sum of x minus 50 over n.
Like you're a terrible student. You're gonna fail. Okay, bother. I'm not asking you another question. You can say it as you can say it as x bar minus 50 is equal to 144 over n.
How do we get here?
So it's, again, how did we get here? There's nothing
Mhm.
to not much to really punch at here. It's just using the formula that we've used in red there clearly. Us saying x minus 50 bar, all we've done is we've rewritten it how we're supposed to in red, right? By saying x
Oh,
bar minus 50 is equal to 144. And so the A in this case is the minus 50.
okay.
Okay. Are we still on the same track here?
I'm processing it. Give me a second.
Take your time. Take your time.
So we're saying we've got x minus a bar, which
Mhm.
is the coded mean, which is this,
Right.
and my a is the 50.
Yeah, the minus 50. Yeah.
But if a is minus 50,
Uh-huh.
then would it not be x minus a?
Sorry. Please repeat your question.
You are saying a is minus 50, if I understand you correct.
Right. Right. Yes. Yes.
So if I'm just substituting into x minus a,
Mhm.
then I've got x minus my a, which is minus 50,
Now I
which
see.
is x plus 50.
Yeah. Now I see. I may have come off wrong there in terms of what's actually happening when we code data in general.
Mhm.
We tend to be subtracting from a a certain value, like we had mentioned before with the example x minus 100.
Okay.
Um, so that minus will always be there.
Okay.
Um, the 50 is the 50 is the a.
Okay.
Okay, right.
Okay. Okay.
So we've just changed the way in how we represent it by saying x bar minus 50 is equal to 144 over n. It's the same thing, just a different way of us writing it. Okay, right.
Okay.
Are we still on the same page?
Okay. Hold that. Hold that. So
Uh,
we've got x minus 50 bar, which is this part here.
right, exactly.
So you're saying I can write x minus 50 bar
Mhm.
as x bar minus whatever my a is,
All right, exactly.
which is x bar minus my 50.
Right.
Oh, okay. I
Okay,
think I follow now.
okay, right. So if you were to go to the MF19, you will come across a formula for bean, right?
Right.
Okay, do you see the formula? X.
Mhm. The summation of xf over
No,
the
no, no,
summation
no,
of
no,
f.
no. We're not focusing on that formula here. In this
Why
case,
not?
our data, our data, our data is not it's not group data. It's ungroup data.
How do I know?
So we don't care skillish. I mean, I don't know. Okay. Uh, that's a good question. It's an important question. But how do we know our data is not grouped?
Hmm.
Uh, why on earth do you think it is grouped? Clearly not. Open your eyes. No, okay, no, actually, this is my question. This is my question. What makes you think it's grouped?
Um, I don't know. I'm seeing a sum,
No, no, no,
and
no, no,
I'm seeing x minus 50.
no. No, but,
So
okay, so let's sort of look at what group data would be,
right.
right? When we have a group data, let me think this out properly. Um, okay, so when we have group data, I'll give an example here, right? We usually are referring to um frequencies and class widths. So take for example, there's a class of 20
Right.
people, right? And we
Uh-huh.
looking at the average height,
Uh-huh.
right? Group data would be portrayed like in the following. You'd say 140 to 150 centimeters, right? And then,
Uh-huh.
for example, you'd have 150 to 160 and 160 to 170, right?
Mhm.
What does this mean? Oh, well, okay. And then we have frequencies. So coming, maybe you should add one more from 170 to 180. So that's, actually, that would make a difference. But anyway, you know, I thought to divide that. So,
What about the guys who are 6 feet?
don't worry, that doesn't include you. So you can, you know. um, yeah. So with C tech is part of the frequency in 140 to 150. So let's see, right? We group the data is anyone between
Mm,
140 centimeters and 150 centimeters would be
mm.
accounted. Even if they're 141 or they're 149, they'd be there. So they count.
Okay.
Let's say in the class there was 6 people between 140 and 150 centimeters, right?
Does
And
that
between
include us too?
does that include what?
Us too.
Us two? What do you mean us two? You big man. That's not me. I actually don't fit into this data representation.
It doesn't have your height.
And I think you just started with a two for me. So
Okay.
from the two hands, this lesson is tailored for you only. So
I see.
examples catered towards you. um, so from 150 to 160, let's say there was 7 people that measured between the heights of 150 to 160, and we had 6 plus 7, 13, 5 um, from 160 to 170, and 2 from 170 to 180. 7 is 13, 15. Yeah, that makes sense. So in a class of 20, do you see how we've grouped our data here?
I
Right.
see, yes.
If it were ungrouped, we'd be looking at individual heights here. We wouldn't be grouping the class. We wouldn't be having class widths like this. If one person was 141 centimeters, we'd be saying he's at 141 centimeters, and we wouldn't necessarily group them into um like ranges of
Oh, so are you saying we'd list out literally all the 20 heights of the
exactly.
people?
Yes, each
Okay.
individual height of the stuff. So let's come back now that we know what group data and ungrouped data is here. You should be able to see that we're not grouping our data in any way here.
All right.
It's ungrouped. There's no frequencies we're messing with here. Okay, we're literally
Also,
some.
if I don't see frequency, then not grouped.
I wouldn't I wouldn't want you to cram it like that.
Okay.
I'd rather you understand the principle. Like we've done nothing to group the data here. We've simply just summed up the each,
Okay.
as you mentioned, the individual heights. It's like we've summed up the individual heights here. We haven't grouped them in any way.
I see what you're saying.
Okay, now that we've differentiated between the two, if you look at the formula for mean for ungrouped data, right,
Yeah.
you come to see that it's x bar is equal to sum of x over n. Okay,
Right. Right.
we keep this. Okay, so we're gonna go there and write down that formula.
Okay.
Right, it's a very important formula. So we're saying that the mean of the uncoded data, right,
Mm-hmm.
equal to the sum of x over n.
Mm-hmm.
Then, though, if you look at what they provided us in the question, they did give us what the sum of x was. So we know that x bar, right, is equal to 944 over n.
944 over n.
Right. That's clear, right?
I
No.
think so.
Okay. So what are we looking for? N,
N.
right? We're looking for the actual number of, well, then I should define what we're looking for. But we're looking for n, meaning the actual number of things that we have, right?
Right.
Now we have two equations that contain x bar and n. What's the first thing that comes to mind with this?
Um. First thing,
Yes, I shouldn't need one thing. I don't know what else you could be thinking of.
I can see X bar.
Right. But normally when you have two equations, right, with two unknowns,
Right.
how would you go about solving
Two equations, two unknowns.
them? Mhm. Two
What
of the same
would
unknown
we
in each
do?
equation.
Two of the same unknowns.
Yes, in each equation. Well, what's the first thing that comes to mind?
Quadratic.
I just finished. You're finished. How would you think of a quadratic? Um,
Let me think.
gentle teaching. Yeah, no, no, it's not quadratic. You come to
Okay.
understand that in the chapter of coded data, you will not have anything to do with quadratics. So immediately keep that away from this.
Wait. Two equations simultaneous.
Exactly. We're looking at a simultaneous equation, right?
Uh-huh.
So we need to construct two simultaneous equations, right? And we're solving for n.
Mhm.
We're solving for n. We wouldn't want to equate them to n. We wouldn't want to make n the subject of both. We'd rather make x bar the subject of both.
Why?
Because we're solving for n. What do you mean?
So would I not make n the subject for both?
No, because if you did make n the subject of both, you'd end up equating. So actually, you know what? Let's make n the subject for both, and you'll see what happens for yourself.
Okay.
If we make n the subject for both, let's do that.
Mhm.
Just
Okay.
no eager to do it. Let's do it. This is
I
gonna
feel
be
bullied, teachers say that.
this is such a complicated process. Why would you think that? Why would you want to make n the subject?
Because I'm solving for n. Should I not make n the subject?
By making it the subject, you're eliminating it from the equation. Because when we make something the subject, right? When we're solving for simultaneous equations, it's to allow us to equate one equation to the other.
Right.
As it currently stands, you can't just go and equate x bar minus 50 and just suddenly equate it to 944 over n. No, they need to be equal values as the subject of the formula so that you can equate the two.
Okay.
Okay. Okay. If we were to make n the subject of the formula, okay, let's try. Let's do that then. Let's do that.
We can multiply both sides by n.
No. I'll give you a shortcut here.
Mhm.
I hope I'm giving you a shortcut here. I'm not with you. Okay, no. Let's just go by your route because I'm not even sure about mine. I know I can.
Okay.
I know I can. Actually, I know I can. I know you're able to just swap 144. I mean the n and the x bar minus, which will go the long route for you. Okay.
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 Are
If
you
we
calling me slow?
no, why would I ever say
I feel offended. Teachers say that.
don't? But let's just say the A is out of the question.
Okay.
What did you want to study when you were in
I what did I want?
what did you want to study for university?
I want to do financial mathematics
Okay.
or
maybe,
actuarial science.
maybe we should look into other careers. Keep our options.
Are you saying maths is not for me?
No, I'm not saying that. I'm not saying that. I think you just have a more creative mind.
Mm, I feel like there's a hidden message behind that. Teachers say that.
You have a more creative mind that shouldn't be confined by numbers. So let's do it as you were saying. In
Mhm.
this case, you'd have x bar n.
But I was thinking then I could divide both sides by x bar minus 50 now.
Yeah, actually, brilliant. That's brilliant. Yeah, great
Thank
idea.
you.
Great idea. Wow, that makes our
Thank
lives
you.
easier. Yeah, 144 over x bar minus 50. See, you could just swap them. But anyways, so see, this is a good trick for you to know. In the case that you have a denominator, right? Um, a denominator that you're trying to make the subject of the formula, and on the left-hand side, you have an expression. You can simply just swap the two because, as you see, it simplifies to the same thing at the end.
Okay.
Okay,
Let's
right.
see what you're saying.
Now, if we make n the subject, let's apply what we just went over there. How would you make n the subject of the formula easily?
I multiply both sides by n.
No, 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 no. Remember what we just discussed, right? That if you're trying to make the denominator of the of an equation, right?
Mhm.
A subject, what's the easiest route to do?
I swap 944 and this.
No, you don't do that. Okay, let's look at our first equation, right? Let's
Mhm.
look at starting. We said x bar
This
minus,
one.
yeah,
Mhm.
x bar minus 50 is equal to 144 over n. Right, then let's look at where we finished.
Mhm.
We ended up at n is equal to 144 over x bar minus 50. So what changed between these two equations?
I swapped this and this.
Exactly. So now you can do the exact same there. So do
So
that.
I swapped this and this.
Exactly. So then, so let's see. Let's do that. So now what do we get?
N is 944 over x bar.
Exactly. Now that we've made n the subject,
Mhm.
if we could equate the two and go 144 over x bar minus 50 is equal to 944 over x bar.
I feel like this is not worth 3 marks. I feel like we're working too hard.
Yeah, it's only because someone made a ridiculous recommendation today. I wonder who that was.
Of the students, teacher.
I wonder who that was.
Learning.
You see how we can't solve for n because n doesn't exist anymore.
But teacher, technically speaking, I can solve for x bar, and then once I have x bar, I go back
Why
here
it
and then
feels
get
like it's
in.
not 3 marks. This is why it feels like it's not 3 marks. Because you're
Ah,
going some very long routes. Right?
so what's the alternative?
Like the alternative, you can put away this whole making the n of the making n the subject. You can just shift that to the side and remember it so you don't repeat that mistake.
I would try.
Okay, so let's look at the right way of doing it. The fastest way, the most optimal way. Most optimal way would be making x bar the subject of the formula. Because as you see, once you make the subject of the formula, when you then equate the two, then, as I like to say, it disappears, right?
Mhm.
Okay, so if we make x bar the subject of both, we can go x bar is equal to 144 over n plus 50, right? Now on the other side, x bar is already the subject of the formula. So
Mhm.
now we can equate the two and say 144 over n plus 50 is equal to 944 over n.
Slow down, slow down, slow down. I don't think I follow what happened.
Okay, so what's happened is you made x bar subject of the formula.
Right. Mhm.
Put that right. Now
Mhm.
that both the subjects of the formula, right?
Mhm.
We're now saying that the two equations that x bar is a subject of are now equal.
Mhm.
That now means we can actually equate the two. Do you get it?
Oh, x bar is this,
Right?
and x bar is also this. So
Exactly.
this must be this.
Exactly.
Okay.
Exactly. So now we can equate the two, which is what we've done here.
Mhm.
Brilliant. Now let's solve for n, because that's the whole idea. Find the value of n.
Mhm.
What do you think we should do to find n?
Hmm.
You said it before, so just try again.
I'm trying to not be dumb. So I'm trying to find the most optimal way
Right.
so that I don't get code slow.
No,
Mm.
no one's putting you slow. Take your time, please. Please.
Uh, so I'm thinking I could put everything that is in on one side.
Okay. Okay.
Putting this and this on one side.
Right, right, right.
Mhm,
So a good rule of thumb, right,
mhm.
to keep in mind is to, in general, try and eliminate your denominators.
Okay.
The reason being is working with denominators tends to get very messy.
Okay.
Okay, so the easiest way to eliminate the denominator, in this case, we're lucky,
Multiply.
yeah, is to multiply by the denominator itself. So if we did do that, what do we get?
So wasn't I right all along? I said multiply by n from the beginning.
Oh, sorry, I thought you said to move it first.
No, I mean our other method was multiplying by n.
Right.
This one, yeah.
Oh yes. No, yes, yes, yes. That idea of wait, what on earth did you do? You took it up. What did you do? Oh, you multiplied by x power minus 50.
I multiplied by n because I had n dividing here.
Is that what we had? Is that the okay? Yeah. Yes, 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 yes. That was originally yes,
Okay.
yes.
So
So
I
that's
just always multiply by n.
well,
And
if
sometimes it's long and sometimes it's not.
no, if
I
n
crap that.
no.
Now I want to make sure I always get it right. So I'm looking for like a rule of
Oh,
thumb.
yeah, no, definitely, definitely, definitely. So a good rule of thumb is for you to leave maths now and go pursue a career in art or something because it's looking no. Let me tell you, let me tell you. It's not an always to 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 multiply by n in this case.
Mhm.
They only happen to be multiplying by n is like I said, I don't we should not it's messy to work with denominators. So where we can, we should try and eliminate them.
Alright.
In this case, we are fortunate that both numbers that do have denominators have the same denominator n, right?
Okay.
So if we do multiply by n here, it would significantly reduce our workload because the n and the n would cancel there between the 144 over n and the n multiplying it. So you get 144, right?
Uh-huh.
And the n
Uh-huh.
is multiplying everything. So what do you get?
50n.
Right? Yes. And then you get that's equal to, again, the n is multiplying on that side too. So it should cancel out. And so what do you,
Okay.
and
944.
yep, brilliant. 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 Now you see we've got a simple equation involving n. Very simple. Right. So how would you solve this equation?
Let's see.
There's not much.
Mm, what you mean there's not much to see?
It's pretty straightforward. It's just a standard linear equation. There's nothing to it.
Yeah, but there's so many numbers and the numbers are big.
Okay, okay. So what I recommend is you start with IGCSE maths.
I did IGCSE.
Core extended.
I did core
Okay, and what did you get?
SC,
Okay, okay, okay.
and my school didn't allow me to do A level, so that's why I'm doing it with you.
Right. Right.
Okay, so I think I can subtract 144 from both sides.
Mm-hmm,
So
mm-hmm.
I move this that side.
Right. Yes, exactly. So
So I have 944 minus 144. My mental math is shocking. I think that's 800.
we've got something in common, don't worry. Right. So now we have 50n is equal to 800. Remember, we're trying to solve for n here. So what do you think the next thing to do is?
I need to get rid of the 50.
Exactly. So if we did do that and we divide it by 50, whatever we do on one side, by a law, we should do on the other. So
Mhm.
n is equal to 800 divided by 50, which is what?
I believe it's 16.
Indeed, it is 16.
Okay.
Right.
And that's the answer.
There you go. N equals 16. Done.
Oh. Okay, so let me just recap this just to make sure I understand what you've told me here.
Go ahead.
So they gave me the sum of x minus 50 and the sum of x.
Right. So let's look at what they've given there, right?
Right.
Actually understand. Those just numbers, but what are they actually giving? The sum of x minus 50. We're saying that the sum of the coded data is equal to 144,
Mm-hmm.
right? So that's what they mean. And most of the time you'll be given a question that contains very similar expressions to the ones that we have now. It's simply saying that the sum of the coded data is equal to 144 and that the sum of the uncoded data is equal to 944.
Okay.
Okay.
Okay. And so if I see this, I just whip out the mean formula.
Not necessarily. Not necessarily. We'll see in another example, right, that it's not always relating to mean, right? Like I said, there is technically three equations that we work with here, as we started with.
So how do I know when to use mean and when not to use mean?
Um, it's very hard to describe this for you here. We'll do another example that involves variance, and then and we'll see how they differentiate from one another again.
Okay.
Right.
Okay.
But carry on with your understanding of this question.
Okay. Okay. So I see sum of x minus 50. So I whip out my mean formula because I think sum of x minus 50, they're asking me to sum the values from the three formulas you told me earlier. It seems relevant to mean stuff. So I get x minus 50 bar is equal to the sum of x minus
No,
50
let's
over
let's
n.
let's sort of look at why we took mean here, right?
Mhm.
Um, with the information we've been given, right?
Right.
Let's understand what we've been given.
Mhm.
When you calculate mean in general, the
Mhm.
idea is to sum up your sample, right?
Mhm.
The values in your sample, and
Mhm.
divide it by how many values you had in your sample.
Right.
So when we look at what we've been given here, right, we've
Uh,
been given the sum of both samples, the sum of
uh,
the sum of the coded data sample, and the sum of the uncoded data sample.
mhm.
Right, so it only makes sense, right, when you look at both equations, right, meaning the equation for coded data of mean and uncoded data of mean. The route that's well, the information that's provided, especially considering that we already have the sum part, it would make sense to then solve from n for n using that.
Oh, so you're saying they want me to find n
Right,
and they've given me the sum. So what formula links n and my sum,
exactly.
which is mean?
Right.
Ah, yeah, genius teacher say that.
We'll see in Beijing. I just got, by the way, I got my statement of entry today. Hey, it's looking pressurized.
Now it's real.
No, it's real. No, it's real. No, it's real.
Okay, so
Carry on though, please.
once I realize that I need something to relate n and my sum, I use the mean formula because that's exactly what that does. And so I'm just substituting this sum of x minus 50 with 144. So I now have 144 over n. Then we whip out teacher Zaidan's formula, which is my coded mean is equal to my uncoded mean
Mhm.
minus a.
Right,
So I then replace my coded mean with my uncoded mean minus a.
right,
And now I make x bar the subject of the formula here.
exactly.
But also, I
Mhm.
know how to find x bar directly. It's just sum of x over n from my MF19.
Precisely.
And the question gives us the sum of x. So I can replace that and I have 944 over n for x bar. And so now I have two equations in terms of x bar and n, and I can solve those simultaneously. And I know I should not make n the subject of the formula, because then I end up with an equation in terms of x bar, which would take me way too long, and I would not do that for 3 marks. So
Exactly.
rather,
That's for three
I
marks.
make
In general, you should never go such a long route
ah,
unless they've asked you to solve for x bar and n.
oh, okay, fair enough.
Right.
So I equate these two because they're both x bar, and then I multiply through by n to get rid of my denominators because we don't like working with denominators. They make life hard. And now I subtract 144 from both sides. I get 50n is 800. Divide both sides by 50, and I get n is 16.
Indeed. Perfect.
Ah, that makes sense.
Right.
That seems easy. Like really easy.
Yeah, sure, buddy, sure. Sure. Sure, buddy.
It sounds like you don't believe in my abilities, teacher Zaydan.
You know, you said you got a C for comment.
Are we doing another example or
Um. Yeah, I think we should do question 2 here.
question 2?
Just so you can clearly distinguish uh between when we are involving the equations with mean or when we are um
The other 3 formulas you were talking about earlier?
yes
Ah,
the
uh, these ones.
yeah your um your standard deviation and variance.
Okay. Should I read the question or
No, we'll go through this one together too.
okay?
Right. A summary of 40 values of x gives the following information. The sum of the coded data is equal to 520, right? The sum of x minus k squared. Okay, so again, sum of the coded data squared is equal to 9640,
Mhm.
where k is a constant, right?
What
Okay,
does that mean?
brilliant question. Um, so you should just know that k is a whole number integer. I think
Can't it be a fraction?
maybe it's a good question. It's a good question. Um, uh, yeah, I can't lie.
I think they just mean it's just any number.
Yeah, yeah. It means it's a member of real numbers.
Okay.
Okay. Yeah, so you're right. It includes fractions, negatives, positives. But honestly, we shouldn't be fretting over that.
Okay.
Trust me, the least of your worries. Um, right. So you see, given that the mean of these 40 values of x is 34, find the value of k. Right. Find the value of k.
Right.
Okay. Let's look to well, to solve for k.
How do we do that?
Sick question, mate. Right, right. Have to give me a moment here so I can look at the question myself too.
Are you stumped? Teacher said that.
No, it's just that I actually need to see the question myself too. You see,
By
and
your own question.
I didn't know, this was just me picking a random question. It was not from my worked examples.
Okay.
Okay. But let's look at the information we've been given. Right.
Uh-huh.
We know that the mean is 34.
Why?
Why? So if you use your eyes and you read, right? It says given that the mean of these 40 values of x is 34.
Real quick, I'll be running a P1, S1, P3, S2 past paper sprint for the CIE, AS, and A-Level Maths 9709 syllabus during April. We'll solve a lot of past papers together live on Zoom, and you get the chance to ask all your burning past paper questions. We'll also have a WhatsApp community where you can get assistance outside of the Zoom sessions from both me and your peers pretty much 24/7. You'll find more details about the past paper sprint sessions in the Google form below. Registration's open in the middle of March, but you can join the waitlist using the first link in the description. We'll only be taking 30 students per class, so make sure you join the waitlist now to secure your spot. Again, it's the first link in the description.
Find the value of k. It comes to see they've given you the mean.
Okay.
Okay.
So this x bar or x minus k bar.
That's a very, very, very good thing we made it. Okay, let's just write down our equation for starters. We said that x minus, okay, we'll relate it to the question here. X minus k bar, right, is
Mhm.
equal to what? What was the equation type?
X bar minus k.
Brilliant, brilliant, brilliant. And we know,
Is this in the MF19?
no, it is not. Don't, it's not in the 19. You
Oh,
better know
so I
that.
have to memorize it.
Yeah, if you don't know this formula,
Oh,
when you
shoot.
encoded data, chances are you're finished.
Okay.
Move on and not waste time. And like someone who spent 10 minutes on a question, no, I'm sorry. Then that's another one of my students. Is, a bit hopeless, but
Right.
anyway, right. So, what is X bar? What is X bar like? X bar in itself, what does that mean?
The mean.
Right. So, let's rewrite this. Right. We know that X bar is the mean, and we've been told the mean. So, 34 minus K, right? Right? What did we do there, Ty? We simply sub what we knew for the mean, right?
Oh, are you saying you replace this x bar here with
Yes.
34?
Yes, because that's our mean.
Oh, okay.
Right.
Okay.
Right. Okay. So as we know the equation for mean, right? We know
Uh-huh.
34 minus k must be equal to the sum of the coded data, right, over n.
Slow down.
Right.
Where's that coming from?
So it's like in the last example, we had stated an equation for mean there, as you can see. In this
This
case,
one.
exactly that one right there.
Okay. Uh-huh.
Only thing that's different here is where you have the minus 50, we do not have that 50. We have k instead.
Okay.
Got it?
Right. So you are saying that I can write x minus k bar as the sum of x minus k over n.
Exactly. Yes. You should probably write that down just so you don't get confused.
Okay, so let me write it on the side. Like this.
Perfect. Right.
Okay.
And you can see that that's going to work out, right? Because it's similar to the first question where they gave the coded data, the sum of the coded data. So that's literally what you're subbing in there is equal to 520. It's the same format, except in the first question, you had a minus 50, not a minus k.
Okay. I see.
Okay. Nice. Good.
See.
Right.
Ah,
So let's work with well, now that you've written that out, we know that the sum of x minus k is equal to what?
520.
Right, and we know n is what?
Do we know n?
We do know n. We do know n. If you read this again, if you read this down of the question, right? What does
A
it say?
summary of 40 values of
Uh,
x gives the following information.
so how many values do we have?
Mm, oh, 40.
Indeed, right? So let's
Right.
520, right? Over.
Ah,
Uh-huh.
so this is easy.
Oh, yeah, sure, buddy. Sure. Wait until you see a bad trig identity, okay? Just straight back to comments. Okay. Um,
Uh,
no, I like the positive mindset. It's good. It's good.
mm,
Right. So just so we get that out of the way, 520 divided by 40 is 13. So 13 is equal to 34 minus k, right? And then we can take k over and make it positive just so we don't have to divide the next. So k is equal to, and then we can take over the 13. So 34 minus 13, right? And if you do 34 minus 13, you get what?
21.
Exactly. Done. Yeah, you found the value of k. Well done.
I'm a genius.
Yeah.
Okay, let me just again go through this and make sure I understand what happened.
You do that big. You do that big. Go ahead.
So, this is one of the formulas you said I must memorize because it's not in the MF9, which is saying my uncoded mean is the same as
Uh,
no, my coded mean is
yes,
the same as my uncoded mean
right.
minus k.
Exactly. The
And in
minus
the
k
question,
is you just coding the data.
okay,
Okay.
okay.
Right.
Like I subtracting by 50, yeah.
Exactly. Like in
Or
the
in the
first
beginning,
example.
subtracting by 100.
Exactly. Exactly.
Right. Okay. I pick it. So here we're told that given that the mean of these 40 values of x, so I
Yeah.
guess that's the mean of x, which is x bar,
Indeed. Indeed.
which is 34.
Exactly. Exactly.
And then we know that the the coded mean is the sum of my coded data
Right.
over n. So I
Right.
can just replace this side with this. And this sum we were given to be 520.
Exactly.
And n, we were told that there are 40 values, so n has to be 40.
Indeed.
So I've got 520 over 40 is 34 minus k. And so 13 is 34 minus k is 34 minus 13, k is 21.
Hold
Okay,
on.
makes sense.
Yep. Great.
Yeah, good teacher Zaitan. I think I'm starting to get the hang of it.
It's just chapter one. Don't worry. Soon enough, you'll lose the hang of it. Anyway, right. Find the variance of these 40 values of x.
Mm,
Now, for variance is very closely linked to standard deviation. If you looked at the initial equations we gave, one was sigma and one was sigma squared. So
right.
you need to go from standard deviation to variance. Simply just have to square the standard deviation.
Okay. I see. Because standard deviation is sigma, and then I square the sigma to get variance.
Exactly. Brilliant.
Okay.
Nice. Okay, so we want to find the variance of these 40 values. So we're really just going to be looking for the standard deviation, right? And then we'll square it at the end to get the variance.
Mm-hmm.
Okay. In the MF19, the formula, I'll give it to you, don't worry. Before you ask 1,000 other
No, I just need to. I know where it
yeah,
is,
just
so
see.
that when I'm writing my exam, I know where to look.
Yeah, okay, good idea. Good idea.
Mm.
Which one do you think we
I'm guessing our data is ungrouped
use?
because I can see that we've got an n, we've got some sums, we have no frequency, we have no classes.
Yeah, exactly.
It's just individual data being summed up to give me this 520.
Precisely. So we're looking at ungrouped data.
Ungrouped data.
Mhm.
And I can see standard deviation has these two formulas. So I'm guessing I can use the first one.
Indeed. So let's copy that formula down.
Okay, square root of the sum of x minus x bar squared. Sigma is equal to the square root of sum of x minus x bar squared over n. I think I copied it correctly. Yes.
Sorry, can you just go up slightly? Hmm. 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 Okay.
Or if you gone quiet, teacher, say that.
No, I'm just trying to evaluate between our equations here. Nothing to worry about. Don't worry.
Okay. I
Right.
thought you stamped.
We hope not. We hope not. Right. So we need to take this step by step, right, and find the sum of x minus x bar squared.
How do we do that?
It's a good question. It's a good question. No, no, no. It's nothing to worry about. It's nothing. Really, it's nothing to worry about.
Mm,
I assure you, it's nothing to worry about.
That's what everyone who's worried says.
Mm. I'm different, Zach. I'm different.
Okay.
Okay. Let's focus here. Let's focus here. Um. Right. I just want to see what equation you had put down there. Okay, and you did not opt for um using that, which is perfectly fine. Don't worry about it. Okay. Now I want you to go back to the MF19, please.
I thought I picked the correct formula.
No, you picked the correct formula from the ungrouped data. There's no doubt. Right. I want you to look at the two equations they give for the ungrouped data standard deviation.
Okay. These two, yeah.
Right. Right.
Mm.
Now, in this case, using the second one, it's
Mhm.
easy.
Why?
Okay, let's go back to our question. Right. Our question on the second part there says the sum of x minus k squared, right,
Mhm.
is equal to no, that is 96 no, sorry, 9,640. Giving me a disease. So like we mentioned before, right, the standard deviation of the coded data is the same as the standard deviation of the uncoded data.
Oh, okay.
Okay,
This one, yeah.
exactly. Right.
Okay.
And that's important. Right.
Mhm.
Now, there's definitely mm, yeah. Okay. So, um, why do we pick the second equation there
Which one?
out of the two from the ungrouped data?
The sum of x squared over n minus x bar squared.
Mhm.
I thought we picked the first one.
No, well, we have, but I'm encouraging you to pick the second one.
Why?
Uh, it's a very good question. It's a very good question. No, it's a fair and justified question. Um, The reason why we don't pick the um the first one is because we don't actually have the necessary values to be inputting there.
Oh, so you're saying we don't have the sum of x minus x bar squared, the
Exactly.
numerator part of this thing. Okay.
In particular, we don't have the x,
But we don't have sum of x squared either in this case.
but we do though.
No, but we don't.
But we do.
But
How do you?
we don't.
Let me explain then. On why we do. Right, we do. We do have it because we said that the standard deviation of um the standard deviation of the coded data is the same as the standard deviation of the uncoded data, right?
Okay.
So
Right.
that formula is given in uncoded data.
Okay. So what would it look like for coded data?
Good question. So sigma is equal to square root sign.
So are we doing it for x minus k in this case?
Yes, sorry. X, yes.
Okay.
Sigma of x minus k is equal to, right? Then sum of brackets x minus k squared.
How do I know I have to put x minus k squared?
But it's a relatively simple thing. Where you see x, you put x minus k.
Okay. So this was sigma x. So where I have x here, I've now replaced with x minus k. So this is now x minus k squared.
Exactly.
Ah,
Right. Over n, right?
so wait. Here I see x bar. So I should replace this x with x minus k. So it becomes x minus k bar squared. Like this.
Yes. But
Yes?
that's very correct. Yes.
Okay, you went quiet for a second. I thought I was wrong.
No, just cross checking that what you're saying is right.
Okay, because I thought it was a simple thing. So I was wondering why you were cross checking.
Yeah, I thought comments were simple too. Anyway. So baby steps, yes, baby steps.
Okay.
Um right, right.
Mm,
So now that we've written out, we can substitute. Okay.
mm.
So sigma x minus k is equal to square root sign.
But teacher Zaidan, I kind of feel like we can just square both sides and get rid of the square root sign because it's kind of annoying to keep writing the square root sign.
Mm, mm.
It's just a thought since we are interested in variance.
Sorry, you want to do what?
I want to square because
Right.
this would become variance and square this side
Mm,
to
mhm,
eliminate my square root sign so I don't have to keep writing square root, square root.
mm-mm.
Mm-mm.
The reason why you should not do this. Right. We're going on a bit of a tangent here. But
Mhm.
if you look at your laws of indices, can you point to it to a laws of indices that allows you to do what you've just done?
If I have, let's say I've got a is equal to the square root of 2, right?
Mm-hmm,
I can square both sides
mm-hmm.
and then I get a squared is equal to my square root and my power 2 cancel out and I get 2.
Exactly. But do you have what you're claiming you have in the question?
Well, I mean, this 2 is basically everything under my square root sign.
Okay, if we look at the first expression, sum of x minus k squared. What's that square applying on?
It's on the x minus k.
Right. So then what about what about the n? It's not on the n, right?
No, my argument is this big square root sign gets
Mm.
cancelled out by the squared because the squared is applying on everything.
I see what you're saying.
Mhm.
Yeah, you could do that. Yeah, you could do that.
You don't sound sure, teacher
No,
Zaitan.
I'm pretty sure you
And
could do it. It's not something I'm fond of doing, but you can do it.
okay, because I figured we could just go to variance straight and
Yeah,
drop the
yeah,
square root.
it's a good point. It's a good point.
So it becomes sum of x minus k. So it's just the square root that's disappearing, right?
Yeah, just the squares. Just the squares.
Okay. All right.
Rightio.
Mhm.
Let's get to subbing. So, sum of x minus k squared. We know that. It's 9640.
Mhm.
Right? Over n, which we know is 40.
Uh-huh.
Right? Minus, right? X minus, okay, hang on. Give me a moment here. We need to first figure out what did we ever encounter that? Bear with me here. No, we didn't. That's fine. It's not a big deal. We did solve for okay. How else can we rewrite x minus k bar? How else did we say we can rewrite it?
As we said, we can rewrite this as x bar minus k.
Exactly. And we know x bar.
X bar is 34.
Exactly. So we're saying 34. And what did we get for k?
21
So 34 minus 21 is what?
is 13.
Huh? Yeah, sorry. Yeah, it is. It is 13. Okay. Um, so,
Mm.
so now that you've got 13, you can just go minus 13 squared.
Okay.
Right. Now, simple calculator work here. 9640 divided by 40 minus 13 squared. That gives you 72.
Okay. But does that answer the question though? Because we've got the variance of x minus k. They asked for the variance of x.
Mhm, mhm, mhm. Now, if you look in red, what it says there, right? He said the variance of x is equal to the variance of x minus a. So the variance of the uncoded data is equal to the variance of the coded data. So yes, we've solved for the variance of the coded data. The
Uh-huh.
variance of the coded data is the same as the uncoded data.
Okay. So
We
I
can
can just say that this is also the variance of x.
squared x. Yes, you can. You can.
Okay.
Yay.
Okay. Okay.
Okay.
This was tricky.
Practice makes perfect.
I see. I see. Let me just make sure that I understand what happened here. So I'll walk you through how I understood this.
Go ahead.
So we went to the MF19. We're looking at variance. We went to the MF19 and we know variance is related to standard deviation. So
Mhm,
we looked at the formula for standard deviation that's provided, and again was doing ungrouped data because, as we explained, we're looking at ungrouped data. And then I initially suggested we use the first formula here, which is the square root of sum of x minus x bar squared over n.
mhm.
But as you enlightened me, we don't actually have enough information to use this formula. We don't have the sum of x minus x bar squared. So this is not going to serve us.
Exactly.
So we must use the second formula, which is the square root of sum of x squared over n minus x bar squared. And on first sight, it's going to look like this formula is also useless because we don't have the sum of x squared.
Mhm,
However, you then propose that we write out the corresponding formula for the sum for sigma of x minus k, which was just replacing the x's here with x minus k. And And then we would eventually see that we've now got sum of x minus k squared, which was provided by the question. So we actually do have enough information to use this formula, but from the perspective of the coded data.
Right. Right.
And then we squared both sides because we didn't like the square root. And so the square cancels out the square root. And then we ended up with this equation here. We've been given the sum of x minus k squared as 9,640. And we were told that we're dealing with 40 values minus x minus k bar. So we know x minus k bar is x bar minus k. We were told that x bar is 34 and we found k to be 21. So
Mhm.
x minus k bar is just 34 minus 21, which
Mhm.
is 13.
Mhm.
And we have to square that.
Mhm.
And if we simplify this, we get that the variance of the coded data is 72.
Mhm.
But from Zaidan's formulas, we know that the variance of the uncoded data is equal to the variance of the coded data. So we found the variance of the coded data, which is going to be the same as the variance of the uncoded data. So the variance of x also becomes 72. And that is our final answer.
Well done. Good job.
Thank you. Thank you very much. Okay, I think I've got a good grasp of this coded data stuff.
Mm. Mhm. Mm. Now we will look at volume of revolutions as the
Mm.
next subtopic.
So we've gone from like 0 to 100 real quick.
No, no, I sent you to. You don't have faith in my teaching.
It seems like you want to make me fail because I
Never.
found the stuff so easy. You want to go to the hard stuff.
You said you got a C for core maths, eh?
I did, yes.
Okay, so let's just work some maths here. Right? An A star in core maths is the equivalent of a C in extended maths.
No, but if you do core maths and you totalize, they give you a C.
Yeah, if you totalize, keyword totalize, you didn't do that, by the way.
Eh, Who says I did it?
You told me you got a C for core maths.
Yeah, the highest symbol you can get for core maths is
Oh,
a
you said
C.
you got a C for core maths.
Yeah,
Wait, meaning you got a C for extended.
exactly. I've
A
got
C
a C
star.
overall.
And an A, so it's an A star in core maths then that you got.
Okay, yeah.
Oh, okay, then maybe we can still do something. And then you're fine, don't you?
There's hope.
Yeah. There's hope.
You sound so hesitant.
If you want to
It
pass.
doesn't give me confidence. Okay.
So
We're now doing volume.
no. Wait.
Okay,
No,
okay. Oh, you're trolling me.
I just wanted you to see the graphs and each other instead.
That's not what teachers do. I'm supposed to encourage the students.
I'm encouraging you. Just keeping
Mm,
you focused.
okay.
Nice. Yeah, do you gonna do another example or are you feeling confident?
I mean, I can do another example, but
Go ahead.
it
Sure.
seems like pretty easy stuff.
Oh yeah, let's see the questions.
It's basic stuff, teacher said.
hmm hmm
Try to work.
Light work. Light work for sure.
Mhm.
For sure. What other question are you interested in doing?
I mean, all of them are easy, teacher said. Give me your worst.
It's a good question. Let's see. Let's see, I read that one here. To be honest, they are very repetitive, as you can see. So when the question comes, you should not struggle. All right, let's do something that we haven't necessarily done, which is number 4. Yeah, number 4 we haven't really done. It just being sum of x squared. So let's give that a shot. Okay.
Shall I read or you want to read?
No, I'll read, don't worry.
Okay.
50 values. Okay, just keep that in mind that we've been given n already.
Okay, so let me note that down.
Right. Of the variable x are summarized by the sum of the coded data is equal to 35, and the sum of the x value squared, so the sum of the uncoded data squared, is equal to 25,036. Find the variance of these 50 values. So as we know with variance, we tend to be working with standard deviation, and either by squaring both sides um, or by squaring at the very end, we'll make it variance.
Okay.
Right. Okay, let's get to work. What do we know here, right? For starters, we can say that let's always keep that mean formula in mind. It's very crucial that x minus a bar is equal to um
X bar minus A.
exactly, yes, yes. Hold
Thank you.
on. Right. So we now know that the uh x minus 20 bar, right,
Mm-hmm.
is equal to x
X
bar minus
bar
20.
minus 20. Okay. Yeah.
All good.
Mm-hmm. Mm-hmm.
And we know that the formula for calculating mean for coded data is the sum of x minus 20, or in this case, x minus 20, right,
Mm-hmm.
over our n, which we know is 50,
Okay.
right? Okay, if you're going to put the n there, then you should replace the minus 20 with, if we're just writing down the formula, it should be, you can just put a there,
Okay.
just so you keep the formula in mind. Okay, and that's equal to, right, in this case, x bar minus 20.
Okay.
Right. Now, if I just want you to go back to the last question. Uh, at the top there. Brilliant. I want you to sort of see the repetition at hand here, right? You see that when we started, it was x minus k bar is equal to x bar minus k. So we're utilizing the same principle here, right?
Mm-hmm.
And again, we're going sum of x minus k over n, right? Equal to 34 minus k. In this instance, we were given the mean instead, right? Instead of the k. And now in the instance in question 4, we were given the k instead of the mean.
Oh, okay.
Do you see it, right? It's very
I
repetitive
see.
stuff.
Uh-huh.
Only so much that they can create here. Okay, so let's not get sidetracked. Let's look to solve for the mean, because that is the current objective at hand, right? So for us to get the mean. Okay,
Why do you need the mean?
because in the formula for standard deviation, right? Let me tell you it quickly. You will come to see that at the end you will always be, well, in both equations they involve x bar, so you need x bar.
Okay.
X bar is the mean. Okay.
Mm-hmm.
Right, so let's sub in with what we know that the sum of x minus 20 is equal to 35, so we're going 35, and we know n is what?
N is 50.
Yeah, so 35 over 50, right? And we might as well drag over that negative 20 to make x bar the subject of the formula, because that's what we're solving for. So
This
30,
one.
yeah. So we take it
Okay.
over, And so 35 over 50 plus 20 is equal to x bar.
Okay.
Hang on, bear with me. I just want to read what we've done. Hope I haven't thrown you off course here. Brilliant. All seems okay for now. Right. So let us proceed. If we were to simplify that, which I will do for you now, you are going to get the x bar as 20.7.
Okay.
Nice. Right. Let us write the. Okay, I need you to look at the question on how it was given. We were given sum of the coded data is equal to 35, and then we were given the sum of the uncoded data squared is equal to 25,036.
Mm-hmm.
We were not given the second equation they gave us was not in terms of the coded data, in terms of the uncoded data. So we will be working with the uncoded data. Cool.
Repeat that.
Okay, so the second equation they've given us, right,
Mm-hmm.
is in terms of the uncoded data.
Mm-hmm.
And so we'll be working with the uncoded data because when we're solving for variance,
Mm-hmm.
right, or standard deviation, we've established that the coded data's standard deviation and the coded data's variance are the exact same.
The
As
coded data standard deviation and the coded data variance are the exact same as.
as the uncoded data.
Oh, okay. Okay.
That's
So
what you got.
uncoded standard deviation is the same as coded standard deviation.
Exactly, precisely.
Okay.
Right. Okay, so a formula from the MF19, right,
Mhm.
is the so we're looking at well, like I said, we're always going to start with standard deviation and then proceed to variance. So we're going to go square root sign sum of
Square root sign. This is sigma
sigma
x.
of x, yes, is equal to square root sign sum of x squared over n minus x bar squared. Okay, nice, good job. So we will now sub in relevant information because we have everything to now sub in, right? So
Mhm.
yeah, we can square both sides because that's what you like to do.
Okay.
So we can get to variance straight away.
Good. So now I've got, I'm just removing the square root sign.
Exactly. Sum of x squared over n is equal to minus x bar squared. Right.
Okay.
Okay. So let's sub in our relevant information. The variance squared, well, not the variance squared, the variance of x is equal to so looking at the information being given here, sum of x squared, which we know is 25,036
Mm-hmm.
over n, which we know is 50,
Right.
minus the x bar, so 20.7 squared.
Oh, so that's why we calculated x bar first.
Exactly, because it's irrelevant to the equation. If we don't have it, we can't use this equation.
Okay.
Right, and you'd come to get 72.23, right? And we know that yeah, never mind. You do have to make a yeah, you do. So we do know that the the variance of x, so the variance of the uncoded data is same as the variance of the coded data. So we can say sigma squared of x minus 20 is also equal to 72.23.
But are we not looking for the variance of x?
That's a brilliant question. Initially, I thought the same, but it said 50 values of the variable x or summarized by. Mhm, mhm. Yeah, that's a good point. That's a good point. No,
Because
you're
I'd
right.
imagine when they said of these 50 values, they're talking about these 50 values.
Indeed. No, you're right. You're right. That we already have it in the correct notation.
Okay.
No need to convert from one to the other. Uh, we round to three significant figures. So
Okay.
1, 2, 3. That's 72.2.
Point two.
Nice.
So that's similar to what we got above.
Oh yeah, it actually, yeah, it is. Wait, can we go to the question above, please? Brilliant. Nice.
What are
Oh,
you thinking, teacher Zayden?
no, no worries. Just verify it. Taking the right route. Over here.
Let's see.
All seems okay.
Okay. I told you it was light work.
Sorry, this is not a light fair, bruh. Are we breaking out of our roles here? Um, no, to be honest with you, before I walked in, I actually had no clue. You don't dictate to me now.
that
How all this works? Like I genuinely had no clue. It just
yeah.
it came now. I'm telling you.
No, but you explained it like very well.
You know what I did? I watched your video. On YouTube. I'm teaching you what you know. Like I have one question.
Mm-hmm.
You know when we were doing this question here, right? I all of a sudden
Yeah.
went x minus 20 bar is equal to x bar minus 20. Why are we allowed to do that?
X minus 20 bar is equal to x bar minus 20.
Yeah, like how can we suddenly just introduce the mean?
That's coming from this idea. If you looked at these, let me just clean this up and rewrite this. So the example that you gave me at the beginning with 101, 102, 103,
Hmm.
104, 105, and when you code the data, you get 1, 2, 3, 4, 5.
Right.
If you calculate the mean of the original x values, these 101s, 102, and so on, you'd get that the mean of that is
What's the mean of the uncoded?
mm-hmm,
Oh,
uncoded mean
103.
103. Mm-hmm. How do you know it's 103?
If numbers are increasing, like if it's consecutive numbers, then it's
Mm,
just the median.
the middle value, yeah.
Yeah.
Yeah. And what does the coded mean?
Well, it's 3.
It's 3.
Hmm.
So what's the relationship between these two?
Oh, it's saying us x minus 100 bar is equal to x bar minus
Mhm.
100.
103 is your, oh, written it the wrong way. The 3.
3 plus 100.
Mhm. This 3
Mhm.
is the same as 103 minus, oh my, minus 100,
Yeah.
which is your x minus 100 bar
Okay.
is equal to your x bar, which is the 103
Okay.
minus whatever value you've used to code.
Okay.
So this is the relationship that you get between the mean when you code your data. It's
So what you're saying that the mean of the coded data is the same as the mean of the uncoded data minus well, whatever a is, in this case
Mhm,
100.
exactly.
Okay, fair enough, fair enough, fair enough.
Mhm. So if you do forget, you can just create this example and explore what the relationship between the two is. But that would mean you have so much time in an exam if you're playing around with things like that.
I hope you guys found this video useful, and if you did enjoy this video and you'd like to see more videos like this, then let me know in the comments down below. And if you'd like to get assistance from my team and I to help you achieve your dream grades, then click the second link in the description down below to sign up for one-on-one tutoring. And remember to join the past paper sprints. It's the first link in the description down below. Again, there are only 30 spots available, so reserve your spot now. Alright, now get off YouTube and go study, but make sure to subscribe before you go. Ciao.